In this lesson, we're going to learn how to use a curve to control our particle flow. So here's where we left off, and you can open up 12 rendering ice end. So now we have our particles rendering nicely. Again, I'm just holding the Q key and drawing this out to create a preview. But we're still have gravity turned off, and I would really like gravity in this simulation. So let's add this back to our forces and click play. So we immediately run into a problem. Our particles are not moving to the next beaker. That's because the gravity is keeping them down. So, of course, with such an open system as ice, there are dozens of different ways to get around this issue. However, one of the simplest and easiest and most controllable, which is an important aspect in my opinion, is to have these particles move along a curve. So now let's come in here and draw a curve that our particles will move along. So first thing is I'm going to go to my camera here, and I'm going to go into my right view. This will give me a perspective view, or a orthographic view, that has no perspective distortion, so that I can draw a curve along a flat plane. So now that we have that done, we can jump over to our model menu, go to curve, and draw cubic by CVs. And now with this done, we can simply left click and place curve points. So let's start by having one point near our particle cloud's top. And now let's just left click and draw a curve around our tube. So in these areas where our curve needs to turn, we need to add a few more points so that it has a nice turn here. And we can just simply move up our tube here, and if your camera is off, you can always hold down the S key to move your camera around. And again, let's add a few points here to bring this in, and let's just add a final point here near the beginning of the last beaker. And now we can either hit enter to get out of the tool and finish building our curve, or we can right click to see the menu and choose exit tool. And now we have our curve in our scene. So let's jump back into our camera here, and let's just rotate around to make sure the curve is placed correctly, and it looks like it is. Okay, great. So now we need to, of course, connect our curve up to our particles. So let's hit Alt-9 to jump into our ice tree again. So first we'll need the curve, and so let's jump into our scene, and I'm actually going to name this first. So you can just hit the enter key to bring up the properties panel of any object that is selected, and then we can come in here and change the name. So I'm going to call this curve flow, just so we can have it a little bit easier to see. And let's hit F3, and let's drag our new curve into our ice tree here. So this gives us a very similar value, or a similar data type to the bounce off surface. So now we need to figure out how we can plug this into our ice tree. So again, whenever we're searching for a node, we could of course try to find something inside of each of these folders, or we could start by searching. So I know we have a curve here, so let's just type in curve. Well, we have emit from curve, and we don't really want to do that. But after that, we have flow along curve, and that sounds like what we want to do. So let's drag this in, and again, it's going to start in an error state because it's looking for a curve. So let's drag our curve into curve 1, and now let's drag the execute into an open port of our ice tree. Now inside your ice tree node, sometimes you'll have all the ports filled up. And let's say we wanted a port between port 4 and port 5, because we want it obviously before the simulate particles. Well, what we can do is we can right click a port and then insert port before. And that will open up a new port that we can connect any of these execute nodes into. So now that that's done, let's play back our simulation and see what it looks like. So I'm just going to hit play. And if we look at this, we can see that we have some very strange thing going on. Our particles are moving straight up, but only in a line. So what's happening now is that this flow along curve is essentially fighting with the gravity node. So there are a few ways around this. Let's take a look at what options we have in the flow along curve node. So I'm going to double left click this. So now we have the properties of our flow along curve. And one of the things we can do to pull particles or make them always move along this curve is to go down to speed control and go down to set new speed. Because when the speed control is on maintain, the gravity is still having its effect. However, if we set the speed, because the flow happens after our gravity node, so we can see here, the gravity tells the particle how fast it needs to be going based off of gravity. But if we tell our flow along curve to overwrite that, we can now get our particles to move along our curve. So let's play this, and now we can see our particles are flowing along the curve. Now, of course, this is not exactly the most beautiful simulation yet, because our flow along curve is having its effect on every particle at almost 100% weight. So what we can do now is use a cutoff distance. So let's enable the cutoff distance and see if the default values will give us a different result. You'll notice that the particles are now still flying out, but now they flow along in a better fashion. However, a lot of particles are still getting caught. That's because we're using a cutoff distance of 5, which is pretty wide. And so we need to reduce the cutoff distance to whatever the width of this tube is. So let's pull this way down to something like 1 and see what that looks like. So the particles are flowing up. We're still getting a few caught, so we can reduce this further. And again, the cutoff distance also helps us control the rate of particles that are going through our tube. Because if the cutoff distance is low, then the particles can sort of get caught but then fall off, as we saw earlier. Okay, great. So now we have a few particles that are getting pulled out of our sort of maelstrom storm in the first beaker, and now they're bouncing over to the second beaker. Now, depending on where your curve is, you might be seeing different results. So to edit your curve after the fact, we can select the curve in the Explorer window and come over here to our selection and change our selection type to point. Now what that will let us do is, if we middle click, well, we have a lot of particles in our scene, I'll just rewind, is now we can select the individual points on our curve and move them. So if we want more particles, we can select the last point or the point closest to our particles, hit the V key or jump over to our transform and hit T and move it down. And what we will see happen now is much more particles will get pulled along this curve. Now, of course, if this is too much, the great thing about ICE is that it is a very well done simulation, so we can dynamically move this curve up and down to control the flow. Now again, we have to be careful because if we move it too high, we're not going to get any particles at all. So as you can see, it is a balancing factor with the cutoff distance and the flow, and the location of the first or the closest curve point. So I'm just going to move this just so I can grab a few of these particles at a time, maybe a few more than that. Again, we have to be careful because a very slight change could have a very large effect with our ICE simulation. So now that we have our curve working, let's take a look at how we can add a little bit more variability and a little bit more randomness into our ICE simulation by using random value nodes. But for now, we have our particles moving along our tube, and we have a very easy way of controlling how many particles and their speed. So if you need to control particles along a path, remember that we have the flow along curve, and that we probably want to turn on the cutoff distance to get a nice, even, and randomly spaced effect.